Hi, happy homeschool day. This is Monday the 16th of March, and we are going to first go over your weekend homework because I want to make sure you understand it, since naming compounds and writing formulas is tough. And then after we do that, then we will get into our notes for today. So your practice problems for writing formulas. So this was your writing formulas practice problems. And there were 8. So the first one was Na plus Cl minus. So your answer should have been NaCl. Because the plus and the minus already balance out, and so they only need one atom of each so that they are balanced. Okay, the next one is Zn2 plus and S2 minus. Okay, again, we see that these charges are equal. There's a plus and a minus, and so, or 2 plus and 2 minus, so we just write ZnS. Okay, please make sure you go back in your notebook and correct these things. We will have a quiz later on this week, and you need to make sure you understand this so that you can do your quiz correctly. Okay? The next one, Zn2 plus and OH negative. First of all, OH, remember, is a polyatomic ion called hydroxide. It's got a negative charge to this whole ion. Okay? And this is zinc 2 plus. So we have a 2 positive here and a 1 negative here. So we need 2 of these to balance out the 2 positives here. So we're going to have ZnOH2, like that. Okay? All right. Next is going to be aluminum, and that is +3, and chlorine, which is a minus. So we're going to have AlCl3. Why? Because there's 3 positives, 1 negative. We need to have 3 negatives to balance out the positive. Okay, so that's how we get that. Your writing should have talked about a little bit almost like cross multiplying, but where this becomes the subscript for this, and this one becomes a subscript for this. Okay, so we'll do a couple more, see if this makes sense. So potassium is K+. We have the polyatomic ion phosphate, so it's PO4 3 minus. So in order to balance out this positive and these 3 negatives, we're going to have K3PO4. Now you don't have to write PO4 in parentheses because there's just one of the ion. If you had to do more than one of the ion, then you would want to do that. Okay, but since there's only one, you just leave it. You don't have to even do that. Okay, next, Pb, 4 plus, and O2 minus. All right, so now in order for 2 to become 4, we have to multiply this one, or we have to have 2 of these. So we're going to have PbO2. Manganese, or Mn, again, this is 4 plus or +4. It doesn't matter how it's written like that, just as long as you know the charges. And then beryllium, or I'm sorry, bromine is going to be minus. So we need 4 of these to balance out the 4 of those. So it's going to be MnBr4. And the last one is an H plus and a Cl minus. Those are already balanced, 1 and 1, so it's just HCl. So there's your answers for writing formulas. All right, so if you're still writing, pause the video, finish writing or checking your work, and then we're going to move on to naming compounds. It's very important that you guys upload your work into Google Classroom for me. I don't want a bunch of different methods of uploading, so I don't want a bunch of stuff coming through Remind and then from email. That'll get lost and you won't get credit for what you did. So when I assign an assignment, you need to take pictures and upload it into my Google Classroom assignment, okay? All right, so this is the naming compounds section now. Number 1 was SCl6. Okay, so S and Cl are, you have to know if it's going to ionically bond or covalently bond. Remember, go back to your notes. When we talk about ionic bonding, happening between a metal and a nonmetal, and a covalent bond happening between two nonmetals. So here we have covalently bonded, and so we're going to get sulfur hexa. How do I know it's hexa? Because of the 6. Okay. And hexachloride. You add the "ide" there when you use these prefixes, okay? So the first one should be sulfur hexachloride. The next one is SiO2. So Si is silicon, and then O2, there's 2 of these. The prefix is dioxide. Silicon dioxide. Again, you don't put dioxygen, you put oxide. Okay? The next one is CaCO3. Now, Ca is an ion, and so we are going to have calcium here. And it's not going to be calcium carbon trioxygen. That's not right, because in this case, CO3 is a polyatomic ion called carbonate. That's one of the ones you had to memorize from that chart. So this is carbonate, and they are equivalent to each other. You don't have to worry about charges balancing. They do that in the formula. Now you're just writing the name. So this is calcium carbonate. Okay, the next one is SO2. So this one is sulfur dioxide. Again, di. Okay, because there's 2 here. And the "ide" because you're doing a covalently bonded compound. All right, next one, PBr3. PBr3 is phosphorus tribromide. Tri because of the 3 for bromide or bromine, and then you add the "ide" because of the covalently bonded metal nonmetal combination. I'm sorry, non-metal nonmetal combination. Okay. All right. MgNO2 2. Okay, so now this one might have been a mistake. You might have had to look this one up, but this should be magnesium nitrate. And I think, if I remember correctly, nitrate is NO3. So if you did NO2, it would have been nitrite. So I think I need to go back and double check that. But magnesium nitrate should be your answer. If you happen to go look up NO2, that would have been nitrite, magnesium nitrite. I didn't teach you that. So again, you want to look in your polyatomic ions, memorize those. NO3 is nitrate. Okay, next one should be P2O5. So now in this one, there's two numbers here. This is going to be a covalently bonded, so we're going to do diphosphorus pentoxide. Okay, di means 2, pent means 5, ide is added to the oxygen. So diphosphorus pentoxide. And the last one is CCl4. So this is calcium tetrachloride. Tetra means 4. There we go. And again, it should have been carbon. This is where the mistake also. If it was calcium, it would be Ca. Okay? All right. So the one that was written there is carbon tetrachloride, not calcium. Okay? All right. So those are your answers for naming compounds and writing formulas. I know it's tough, and this isn't the best time for us not to be together, but it is what it is, so let's make the best of it. My plan is to, once a day, have basically office hours online. And by doing that, you guys can drop in and ask me some questions if you're struggling. Okay, so look for that to come up at some point. My plan is to get it planned today, but I need to teach all my classes first. So goal is to teach, then to work on office hours. All right, so let's get to your next set of notes. Chemical reactions. Okay. So your question for today is, why are coefficients so important? Your heading is chemical reactions. And so we're going to do some definitions first. The first definition is, what is a chemical reaction to begin with? A chemical reaction is a reaction in which one or more substances are changed into new substances. Okay, so we start with something like water and glucose, and we end up with, or we start with water, oxygen, and carbon dioxide, and we can make new substances. We can take apart glucose and make it into something else. Those are chemical reactions. Okay, we're going to draw some in just a second. So in order for us to understand a chemical reaction, we need to know the parts of a reaction. So first of all, we have reactants and we have products. So reactants are the substances that are about to react. and products are the new substances produced. Okay, so let's draw a little picture. We have reactants, an arrow, and then products. So reactants produce products here, okay, through a reaction, a chemical reaction. Now, just like with every topic we've studied, there are the laws that kind of come into play. So we have to be reminded of the law of conservation of mass. Okay, the law of the conservation of mass is that the total starting mass of all reactants, total starting mass of all reactants will equal the total final mass of all products. Okay, easy enough. Again, if you weren't done with that, just go and pause and rewind for a second. All right, so let's define what a chemical equation is. Because now that we know what a chemical reaction is, it comes from, we write chemical reactions in the form of a chemical equation. A chemical equation, it uses chemical formulas and symbols to describe a chemical reaction by the way, from now on, RxN is reaction. I may not write the word reaction every time. And so to describe a chemical reaction and the product it produces. Okay, so let's draw a chart. We are going to draw a chart of symbols and meanings. So you're going to need to go all the way across the page. It'll be 4 columns and 1, 2, 3, 4, 5, 6, 7, 8 lines. Okay, the headers are going to say on the top symbol and meaning, okay? All right, so let's all right, so let's do the first one, which is the arrow. The arrow means produces or yields. The next one is plus, a plus sign. It literally means plus, just like in math, like you're adding something together. If you see an S in parentheses, an L in parentheses, or a G in parentheses, it means solid, liquid, gas. Okay, going over here, we have some more symbols. If you see AQ in parentheses, AQ means aqueous, which means water. It has water, okay? Or it's dissolved in water, a solid dissolved in water. So put that out to the side. Solid dissolved in water. Okay? If you see over the arrow heat, light, or electricity, those are, you're going to write that the reactants were heated, the reactants were exposed to light, so reactants heated, reactants, oops, spelled that wrong. To light, and reactants that were had electric current applied. Okay? All right, so these are the symbols or meanings of those symbols when you're writing a chemical equation. So let's write an example and label some of it so that you see what I mean. If you have not finished copying this, just go ahead and pause it until you're done. All right. So, let's review some what coefficients are, because that's going to come into play here as I need to dry this a little more. Okay, so coefficients. Remember, coefficients are the numbers that represent the number of units of each substance. In a reaction. Okay, so let's draw one of these. Let's say we have 4 units of aluminum in solid form. Does everybody see that? 4 is the coefficient. That means 4 units of. Al is aluminum. Aluminum in solid form. Solid is in parentheses there. So 4 units of aluminum in solid form plus 3 units of oxygen. And actually, don't put this in parentheses. Just do 3 units of oxygen in gaseous form. Okay, oxygen isn't happy alone, but it bonds with itself really well. So you are going to see oxygen in O2. It's always going to be in the O2 form. Okay, and then this, when you do this reaction, it yields 2 units of Al2O3. Okay, so this is a chemical reaction, okay, or a chemical equation written out. Here are my reactants. Here is my product. Okay, in this case, there's one product. These combine and form that. We know this is in solid form. This is in gaseous form. That doesn't have a form listed. This right here, and this right here are all coefficients. This right here and these 2 here are subscripts. Remember, those tell me how many of each atom. This tells me how many units of the whole compound. Okay, so we have 4 units of aluminum. We have 3 units of oxygen, but if I asked you how many atoms of oxygen, you could tell me 6 because there's 3 times 2 each. So that's 6 atoms of oxygen. This one, we end up with 4 atoms of aluminum and 6 atoms of oxygen. It's balanced on both sides. We'll get to balancing chemical equations later. Okay, so the last thing I want you to write here is a reminder of what subscripts are. And by the way, you can write reactants here, products here, and then those arrows are coefficients, and these are subscripts. Okay? All right, so subscripts, rewrite this definition. These are the numbers which represent the numbers of atoms in a molecule. Of a particular element. Okie dokie. Those are your notes for today. Please make sure you understood the naming chemical compounds and writing formulas. I will likely have you guys do another practice page of those separate from your interactive notebook because they are tricky. And we will be working with these chemical reactions. So if any of this doesn't make sense and I post a time for office hours where you can come and see me on a video chat, please do that to ask questions. Okay? All right. Have a great day.